Howdy! Since I'm not here today, I wanted to make some videos that walked you guys through some of the trickier problems on our notes. Starting with problem number 11. This is problem 11 on our notes. And sorry, I scanned it weird, so there's a little bit of funny business going on as far as the letters. All right. When we were talking about graphing, like solving a system of equations by graphing, remember what we're looking for is two lines that will cross, and the solution or the answer is right there where they cross, and so that's what we're looking for. Here's the answer. Okay, because that's our answer, we are going to go ahead and we're going to try to graph these lines. A friendly reminder, to graph a line, I'd like it to be in slope-intercept form, which looks like y equals mx plus b. Y equals mx plus b. Please notice that right here, the y is all by itself. That's our goal, is we want y to be all by itself. So let's take another look at these two equations, and we'll see if there is a way to get y by itself. By the way, part of the reason this one's trickier is because if I go to any of the other ones, the y's are by themselves. So this one bumps it up a notch because you have to get y all by itself. All right, let's jump in. I'm looking at just this first equation here. Now, if I look at just the first equation, here's the equal sign, and it appears that y is not all by itself on one side of the equal sign. Geez Louise, we've got a negative x. So to get rid of negative x, and you know what I think I'm going to do so I have a little bit more space, is I'm going to write this equation over here. So I'm going to say y minus x equals negative 2. Now again, I would like to get rid of this negative x so that the y can be all by itself. Okay, how do I get rid of a negative x? Well, I believe the opposite of negative x, or the way that I would undo minusing x, is to add x to both sides. Those two cancel. X minus x is 0, the same way that 2 minus 2 is 0, so x minus x must be 0. And then I'll get y equals x minus 2. Right? These two friends right there are not like terms, so I can't combine them. If I can't combine them, I'll just write them side by side. Now, let's jump into graphing this guy. Okay, so first thing I want to look at is B. B stands for beginning. I don't know how to spell beginning. That looks good enough. I start with my beginning point. This is also known as my y-intercept. The y-intercept tells me where to start on the y-axis. It looks like it's at negative 2. So I'm going to put a little dot 2 spaces down from the middle. Okay, and that's my beginning point. Now let's move on to the slope. Remember, the slope tells me how far up and over to go. Maybe I'll go up 5, over 2, whatever, right? The slope tells me where my next point should be. So let's take a look, and I thought the slope was supposed to be here in front of the x. I'm not seeing anything, though. Please recall that when there's just a letter floating all by itself, remember, we've got a secret invisible 1 right there. This 1 is very secret, it's very invisible, but it's there. Anytime you've got a letter just sitting by itself, it always has a secret invisible 1 in front of it. Okay, we've solved one problem. I figured out where the slope was, but we've landed on another problem because I thought slopes were supposed to be fractions. In order to turn this slope, this 1, into a fraction, I need to divide it by something that will not change the value. Something that we can divide anything by that won't change the value is 1, so we can divide it by 1. Remember, slope is the same as rise over run, which is the same as how far up and down are you going over how far right and left are you going. Okay, it looks like since on top it's positive, I'll be going up 1, and on bottom it's positive, so I'll be going right 1. If they're both positive, I go up 1, right 1. So up 1, right 1, and here's my new dot. Up 1, right 1, here's my new dot. Up 1, right 1, up 1, right 1, up 1, right 1. Additionally, if I can go, oops, I meant to have my pen there. There we go. Additionally, if I can go up 1, right 1, so if I've got +1 over +1, I can also do -1 over -1. Meaning I can go down 1, left 1. The reason that these two work out and they end up being the same is because here I've got a positive divided by a positive, so that'll end up being a positive. Here I've got a negative divided by a negative, again ends up being a positive. So they both end up equaling the same thing, a positive. Okay, so I'll go down 1, left 1, down 1, left 1, down 1, left 1. Okay, and I can draw in my line. Okay, and we're good to go there. Right now we got our first line graphed. Now I am going to jump into graphing my other line. Let's pick a fresh new color. How about purple? I'm going to move this guy over here just so I have a little more room. In fact, I'm actually going to move him a little bit further. Let's go right here. So I've got -y plus x minus 2 equals 0. Okay, now there's an easy way to do this and a hard way to do it. I will show you both ways because I could see myself trying to do either way. Let's start with the easy way. Again, my goal is to try to get y all by itself. Right now there's a negative sign in front of it. We're adding x and we're minusing 2, and all that's on this side is a paltry 0. So the easy way to do this is to be like, okay, well, everything's over here. If I'm trying to get y by itself, then I'll just move it to the other side because there's nothing over here but a 0. So that's the easiest way to do it, is just to be like, oh, well, if everything's already over here, then I can just move the y off of this side and I'll solve all my problems, basically. The way I would do that is I would say plus y, that cancels, and I get x minus 2 equals y, which I could then rewrite as y equals x minus 2, and now we're in y equal mx plus b format. Now, you can do it this way. This way's awesome. It's rad. It's great. 10 stars. Let me show you the way, like looking at it at first, this is the way in my head that I was like, okay, this is how I need to solve this. And so I want to make sure I show you both ways. So -y plus x minus 2 equals 0. Again, I'm trying to get x by itself. The first time I looked at this and was thinking about solving it, I was like, geez Louise, I'm going to have to move this over here. I'm going to have to move this to the other side, and then I'm going to have to take care of this negative. So let's do that. Okay, the opposite of adding x is minusing x, so I'm going to minus x from both sides. I'll have -y, that cancels, minus 2 equals -x. Oops, that is not an x. There we go. Okay, I still have got this silly boy right there. We got to get him to the other side. So I'm going to go opposite of minusing 2 is adding 2. Sorry, I should have said subtracting 2, whatever. Okay, and I'll end up with -y equals -x plus 2. Now, you may notice I still have this -y. Secretly, that's -1. -1 times y. Well, what's the opposite of -1 times y? Is dividing by -1. So I'm going to divide both sides by -1, meaning I have to divide everything by -1. These folks cancel. I get y equals, okay, here I've got a negative divided by a negative. That is going to become a positive, so I'll end up with positive x. Here I've got a positive divided by a negative. Again, the negative is going to overpower there, so I'll have minus 2. If you look back in the video, you can rewind or whatever, and you'll see we've gotten the same answer here. All right, now on to graphing. Beginning point tells me where to start on the y-axis. It looks like looks like I will begin at -2, right here, two spots down. Okay, and then we've got a secret invisible 1 in front of this x. Slopes are supposed to be fractions, so I'll also divide by 1. This is telling me I go up 1, right 1, up 1, right 1. So I'll go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. If I'm allowed to go up 1, right 1, I'm also allowed to go down 1, left 1. Down 1, left 1, down 1, left 1, down 1, left 1. Jeez Louise, we have got the same exact line here. Remember, the solution, or the answer that I'm looking for, is a place where two lines cross. It's the place where two lines cross. It kind of looks like, well, or in other words, a place where the two lines are the same. Right here where they cross, we can say that both lines have this point on them. Both lines are the same right here. For this line, it looks like both lines are the same for the whole thing. Meaning that every single spot on this line, every single dot, every single place in between these dots, every single spot on this line off to forever is exactly the same. So, we'll say that the solution to this problem is all real numbers, which you write as a capital R with a line through it. You can also spell out all real numbers, which I'm fine with either. Okay, good luck. I believe in you guys. Have a great rest of your day.